Before you start taking any light images of your desired object, you will need to first focus the telescope. Generally, it's fine to focus just once if you're using multiple different filters, but if you want to be more precise, you may want to refocus before using each filter. In order to focus the telescope, you will need to locate a group of calibration stars. For our purposes, we will use Stellarium to both find our calibration stars as well as slew the telescope to point at them. Generally, you'll want to search for calibration stars within the band of the Milky Way where stars would be plentiful and or near the object you're observing so that you can more accurately account for atmospheric interference while you're focusing. You'll generally want to look for groups of stars between magnitude 7 and 8 and avoid stars brighter than magnitude 6 and dimmer than 9. This can vary, however, depending on what stars you're observing and what filters you're using. Here I have a group of calibration stars. You'll be able to see in the top left corner the magnitude of the selected star. This one's a magnitude 9.8, this one's a 6.9, got an 8.1, a 7.8, a 6.8, and an 8.7. We have a good 3 to 4 near that magnitude 7 to 8 range. Not ideal number of stars or magnitude, but good enough for now. Now that you have a group of calibration stars, you can select the centermost star of the group and press Ctrl 1 to automatically slew the telescope and point it at that star. Before you use the autofocus tool to focus the telescope, you should take a quick test image to see how many stars are actually in the camera's field of view and how bright they appear using your selected filter. Double check that your desired filter is selected in the filter wheel control window. Now open the SAO Image DS9 application so you can display your image. Then navigate to the camera window and make sure you do not save this test image. You only take one test image. Set your exposure time to about 2 to 5 seconds, same as the autofocus, and make sure your exposure type is light. Now hit expose to take your test image. For us, it looks like we got a good deal of stars in our field of view. You can clearly see that they're out of focus since they look like little rings and not dots of light, and they do appear fairly bright and don't sink into the background noise, so this should be good. Once you have found a good enough set of calibration stars, you can now navigate to the autofocus window. Something to note while using the autofocus, the telescope uses the last known focus value before it was shut down as its new zero focus value when you start it up again. This means that 0 will generally be the best focus value most of the time and is a good value to center your maximum and minimum focus values around to start with. In our case, the current focus given by the focuser window is negative 10,000 since we were taking flats a little while ago. It would be best to start by centering our focus around 0, but just for demonstration purposes, we'll center around our unfocused negative 10,000 value. You'll want to set your minimum and maximum values to about 10,000 to 5,000 units from your center focus value. In our case, we'll set our minimum focus to negative 20,000 and our maximum focus to 0. The number of images you take with the autofocus is mostly up to you, but if you're unsure, you can start with about 9 or 10. In our case, we'll go a bit on the higher side and take 15. Your exposure time, however, would be best kept in the 2 to 5 second range, depending on how bright your calibration stars appear with your current filter. Once you have specified your settings, hit start and the autofocus tool will start taking images. The images taken by the autofocus will appear in the DS9 window you opened earlier, and you can watch as the stars go in and out of focus. Once the autofocus tool is done, it will display a graph and a recommended focus value. If the graph shows a smooth curve towards the recommended value, go ahead and hit accept. If the graph is not a fairly smooth curve, do not accept the recommended focus value and instead change your minimum and maximum focus values and try again. You might want to make the minimum and maximum focus values 10,000 units from the recommended focus just to give it a shot, but sometimes it's usually just best to start back at 0. Once you have a group of calibration stars that produces a smoothly curved graph using the autofocus, accept the recommended focus and you will be ready to take your light images.